Hi, I'm Tim Berglund with StarTree. When I tell people that Apache Pinot is a real-time analytics database, sometimes they say, really, another database? Is that really necessary? And it is, but it's a fair question, and I'd like to talk about it a little bit here. So you got the problem of real-time analytics, that is, serving analytics to users on live data interactively in a user interface. There are some technologies that folks have tried using prior to Pinot, and I'd like to talk about them and evaluate them in a few dimensions. So the technologies are going to be, let's say, we'll start with key value store, and key value store gets the database drum. It's his lucky day, and we'll say search technologies, maybe like Elasticsearch or something like that. And that we'll just give that a box there, and we'll say the good old data warehouse. That can be a contemporary data warehouse technology, something cloud-based like Snowflake. It could be a data lake, S3 with Spark jobs or whatever sorts of infrastructure you've got on top of that. We don't need to make that some ancient straw man of a data warehouse. It's something that you've probably got fielded in a responsible organization. All of these technologies have a place in the world, and all of them have been used and still may be used in some cases for doing real-time analytics. Let's evaluate them on a few different dimensions. So I want to talk about freshness. How old is the data that we're querying? We'll talk about latency. How long does it take for a query to execute once it's issued? How long do I have to wait to get results back? Let's talk about throughput. Really, how many queries per second can I expect this technology to handle before it falls over? Now, these change. Remember, in real-time analytics, I'm going to expect very low latency. And because I don't just have a few people refreshing a dashboard, I have a potentially large user population hitting the database, my throughput, my queries per second is going to be very high. So I'll have expectations there. And I also want to talk about flexibility, by which I mean, what kind of queries can I throw at it? What is it really going to do for me when I come up with a new kind of query? Is that going to be difficult? Is it going to be easy? And we might, in a few cases, we might talk about cost effectiveness if that comes up in an interesting way. All right, so let's just go through our options here. We've got our key value store. First of all, we're going to have a definite happy face when it comes to latency. Okay, that's why these things exist. They scale. There've been commonplace key value store technologies for a decade and a half that have just been open source options, all kinds of things, and they're fast. They're big and they're fast. So latency and throughput, number of queries you're going to be able to hit there, key value stores are going to do just fine. On flexibility, though, you're going to get, I think, not just a sad face, but a very sad face, because what you're doing really is you're pre-cubing. Okay, you have to go to the source data, pre-compute all the aggregates, and write those keys into the key value store. Anytime you've got new data, you've got to rewrite those keys. Anytime you've got a new kind of query you're going to write, more dimensions you want to add, you've got more keys to write. So there's this robust, high-volume write process, and frankly, complex software that now you have to write, taking on database responsibilities to yourself, which I'm going to say is a little bit of overfunctioning on your part in order to get that done. So flexibility, definitely not a win. And freshness, same thing, is at best neutral, because you have to do all that rewriting. So there's going to be some kind of batching that's going to happen, and that might make that a little bit of a frown there. Okay, so and cost, that can be a win. We'll come to that later when we come to data warehousing. We'll just kind of leave that for now. Let's talk about search. Again, do you have search deployed in the world of your data? You may well. Okay, it's a very common thing. And it's a very good thing. This is a thing that we often need to solve other problems that are search problems. Can you build real-time analytics on top of search? Well, let's take a look. You might have decent latency. That's not like a super joyful smile there, but that's why you would consider using your existing search infrastructure, because you think the latency can get you there. Not sure about throughput. That's going to be a little flexibility. Same thing. Really what the search infrastructure is returning to you is documents that match with some ranking. And in terms of the roll-up that you're computing, since we're assuming basically we're filtering and aggregating our data for kind of bread and butter analytics queries, you may be doing that aggregation yourself again. So you're kind of taking that responsibility onto yourself. So you might feel like you have some flexibility, but the system itself is not really doing much for you. And freshness, again, potentially not great. You're probably going to have, again, even if it's micro batching, some kind of batching to ingest from a streaming data source. So this looks so bad. There's a slight kind of wry smile there, and everybody else, you might think, are you just setting this up to look terrible? Well, no. The reason why this happens, the reason why search tools get deployed in the service of real-time analytics use cases is because, again, you have one lying around. You're doing search things responsibly and effectively with it. It's doing well there. And you think, well, the data's there. I've got the infrastructure. Let me just build this new thing on top of it. So that's a reasonable thing to try. But again, results typically not great. So let's look at the data warehouse. Let's start with where the win is. And that is a big, bright smile on flexibility, sort of beaming, very happy. You can kind of do anything you want, right? You want to do joins, that's great. Do joins. You want to do subqueries, window, whatever it is, you've probably got full SQL there. So definitely very, very flexible. Latency, no. Okay, these are just generally not real-time technologies. And again, they're not bad technologies. Don't get rid of your data warehouse. They're just not built for that use case. They're built for, think of the technologies that precede all this, reports that turn into printed paper on a laser printer, which only later became a web-based dashboard. And instead of printing once a day, if it refreshes every 15 minutes, it's a huge win. So the latency characteristics that they're built for just don't translate to real time. They do their job well. They don't do the real time job super well. Throughput, same thing. These are built for a small number of queries per second. You may be able to scale them up, but we'll talk about what happens with cost there. Freshness, it's probably not great. Again, increasingly, everybody needs to have a streaming story. There are ways to ingest data from Kafka in pretty much all of these, obviously, but they're not built to turn that around right away and give you great results. Now, cost becomes kind of interesting. If we look at, let's draw a little graph here, and if we look at throughput there and money there, you've got a thing where at low throughput and low amounts of data, you may have very low cost, but that cost tends to rise as throughput goes up. And there's going to be a point with latency and throughput where, it's always with latency and somewhere with throughput, where these systems just aren't built to do 100,000 queries per second. They're not going to do that for you. So let's take that, and with that, we'll go, rather than a database, it is of course a database, but I'll draw the good old Pinot wine glass. That does not look like a glass you'd serve Pinot in. That looks more like a goblet of some kind, but we're going to work with it. So Pinot is a database. It is a real-time analytics database. And let's look at how it stacks up here, having been purpose-built for these requirements. So I'll start at the top. Freshness, big, bright smile, okay? Pinot can ingest batch data sources if you've got batch data lying around. If you've got streaming data, you can connect Kafka topics to Pinot tables, and they ingest at very high speed, hundreds of thousands of messages a second. And as soon as a message is ingested from that Kafka topic, consumed from a Kafka topic, it's available for queries. So there just isn't any additional latency that Pinot imposes on your streaming pipeline. Latency, hard to do a lot better, again, for the bread and butter, filter and aggregate types of queries on practical, large production data sets. There are real-life P95 latencies in the tens of milliseconds on real live data at scale. Of course, there are queries that you can write that take longer, but again, you can get to very much real-time results where a user, providing some kind of input, kicking off a Pinot query on the back end, and those results coming back and being turned into some display in that app or website or whatever it is, that's going to feel very much alive. So latency win. Throughput built for the hundreds of thousands of queries per second in its initial use cases at its inception. It takes a large cluster to do that, but that's absolutely doable. Tens of thousands, not unusual. Thousands of queries per second. Those are amateur numbers, so that's easy to do for Pinot. Flexibility, can it all be a win? We're gonna say we're starting to smile there with what's happened recently in Pinot with the multi-stage query engine. Now we in fact have joins between large tables, so-called fact-to-fact joins. And that multi-stage query engine technology is going to allow the build out of a more complete ANSI SQL subset as time goes on. So that flexibility is going to eventually turn into just a full smile, and you can do anything you want. Of course, there are limitations now, but those are falling, and it really is a happier thing. When it comes to cost, interestingly, to be Pinot and to be purpose-built as a real-time analytics database, there are things you have to do. You have to make decisions, for example, that storage and compute will usually be tightly coupled. Compute resources are going to be pre-allocated. So you're gonna build out a certain number of servers and brokers in your Pinot cluster to store data, and that computation on those queries is going to happen at the server level. You've got those resources there, which means on the low end, you're going to find cost is higher than the low end of, say, a data warehouse, but that's going to grow at a lower rate. And so at some point here, before throughput gets too far, you've got this crossover point now where your data warehouse is actually going to cost you more and be slower and be less fresh, and also be more costly. And you'll see Pinot growing at a more linear rate, at frankly a pretty reasonable slope. So you get that crossover point fairly early on in your history. So there you go. Key value stores, search tools, data warehouses, Pinot itself, with these key characteristics: freshness, latency, throughput, flexibility, cost characteristics. If you look at what you need to do to be a real-time analytics database, it really does shine and make sense. There are times to deploy those other technologies, problems to solve, use cases to address with them, and they ought to be a part of your world. But when it comes to real-time analytics, Pinot really should be the thing. So if you want to find out more, come join us on the web. We've got lots more to help you in your Pinot adoption and understanding journey, and we would love to hear what you build. Thanks.